Lesson 3 of Unit 2 addresses surface modeling, and surface modeling is used to create a representation of the existing ground prior to your design. And you may extract items such as surface profiles, existing ground cross sections. From the surface model, you may set spot elevations or slopes on that surface model for labels, or you simply may wish to display that surface model as contours for your plans. In Lesson 3, there are a number of exercises. You learn how to create a surface, modify the properties of the surface. You learn how to edit the surface, create surface styles, assign a contour style and apply surface labels. And you also learn how to export a surface to Google Earth. Civil 3D represents a surface as a tin, a triangulated irregular network. This is a type of DTM, which is a digital terrain model. Essentially, all of the points are connected based on 3D proximity, so the closest points are connected, and it forms a network of triangles. And the only rule is that the triangles cannot cross each other. And these triangles are used for contour creation and for surface profile section data point generation. So you can see how the triangles are actually pulling the contours in certain directions. So it's really important that these triangles go in the correct directions, i.e. along the terrain breaks. In Civil 3D, you can create surfaces from a number of different objects, including points, break lines, contours, boundaries, and AutoCAD objects. And you can see here that break lines are required for those distinctive terrain breaks, being crowns of roads, edges of pavements, bottoms of ditches, and those sorts of features. Here's an example where there's no break lines defined. You can see the triangulation does not follow the crown. This is a problem because if we were to create a sample line across here for a cross section, you're going to miss the crown of the roadway. And here's an image that shows the break lines formed correctly. So let's have a look at surface modeling here. So we now have a drawing in here with a number of points. If we go to the point group collection, we have the existing surface definition point group. We can right click on surfaces and select create surface. The name will be EG for existing ground, and the style is contours and triangles, and we click OK. So now we have a surface in here called EG. We have not yet indicated which data to build that surface from. And that's done by expanding the definition tree, and you can right click on point groups and select add, and we're going to use the existing surface definition point group. And when I click OK, that surface is created. Once again though, notice that the triangulation line does not follow along the break lines, the edge of pavement line here for example, and then the crown line. So this surface needs some work. There's a few things that we can do here. Before we go into modifying the surface properties, let's define the break lines. So what we'll do is, the surface is now being displayed as contours and triangles. Let's just quickly modify this surface style. And under the Contours tab of the Surface Style dialog box, we're going to increase the contour interval to 0.5 and 2. And that will tighten up the contours. So if you look, the contours don't look all that representative. So what we can do now is we can define break lines. Now all of these features here are 2D polylines. So it's important to note that they are indeed 2D polylines. Even though they have an elevation assigned, they are 2D polylines. So we are going to define those as proximity break lines. A 3D polyline, you would use a standard break line. So back to the definition tree for that surface. You right click on break lines and select add. Because they're 2D polylines, we're going to use a proximity break line. And when you click OK, you're prompted to select the objects. Now let's just select these objects, and before I finish and make the selection, just watch what happens to the tin lines and the contours as soon as I press enter. Well, you can see now the contour lines run a lot cleaner, and now the triangulation lines are forced along those break lines. And the panorama window here displayed some processing errors, and these are indicating that the break lines were crossed. And obviously, when triangulation lines are forced along a break line and triangulation lines cannot cross each other, there is a conflict there. So from panorama, as always, we'll clear the events, and we can resolve these crossing break lines by modifying the properties of the surface, either here with the right-click menu or from Tool Space, right-clicking on the surface name and selecting Surface Properties. And under the Definition tab, we can expand the build tree, and we can turn on the use of allowing crossing break lines and average the break line elevation at the intersection. So these would have been in instances where perhaps a gutter line intersected with a driveway, and it may have crossed over by just a fraction of the distance. So when we click OK, we can rebuild the surface, and the crossing break line issue has now been resolved. Okay. So the other, if we keep on going here, when you modify the surface properties, that's where you can allow the crossing break lines. There's a number of other things that you can do here. We can go into surface properties and set the maximum triangle length. So I'll set that to yes. And let's pick 2 points in a drawing to specify the value. So I don't want the triangles to be longer than those 2 points there, 54. Why don't we round it down to 50 and click OK and rebuild the surface. And now you see how we've deleted a number of those long triangulation lines. Okay, back to the PowerPoint. You can also edit a surface by deleting lines and adding lines, and this is a fairly common thing to be able to delete lines, but you need to see the lines to be able to edit the surface. So if we were to go back to the surface definition, right click edit, you can delete a line, and then if we just pick a line here, you can see how deleting that line update the surface definition. So we can use a crossing selection set to delete some of these long unwanted triangulation lines, perhaps in the corner locations, and those are displayed as edits in the item view area, which then can be removed. So I can delete the deletion of a line, so I can actually modify those edits. You can also swap an edge, and this is typically done to clean up the contours. You're not going to want to be using the swapping edge command for break lines. You should be using break lines in the first place. And as I just displayed, the edit history allows you to review and delete any edits you made on the surface. Surface styles are used to control the display of the surface object. So if we click back to Civil 3D, under the Settings tab, here's all our different surface styles. The one that we have in use is called Contours and Triangles. If I right click on that and select Edit, under the Display tab you can see that the triangles are being displayed with this layer. However, if I wanted to, I can override that, make the triangles 1. Now they're red. And I can modify the properties of the surface, and under the Information tab, assign the style here. So if I'd like to see just a border, there's just a border of the surface. I can elevation banding, that's a style to shade the surface based on elevation ranges. Slope banding to shade the surface based on where your flat, where your steep areas are. And if I want to display contours, those are your contours. So a number of different ways to display surfaces using surface styles. And you can also label a surface. So you can label slopes, spot elevations, you can label contours on a surface. And here's examples of a spot elevation label and a slope label. And you can also export a surface to Google Earth. So let's go through that. If we were to go to the application menu and export There are a number of options for exporting data to different formats here, but under Publish, you have Publish to Google Earth. And this is important because it uses a coordinate transformation. Actually, I'm not going to do it in this drawing because this drawing has not been set up properly. So let's just go to another drawing. It's actually needs to be one of the metric drawings in here. We'll open this metric drawing. And to review how this function will work, under the Settings tab, if you right-click the drawing name and select Edit Drawing Settings, you can see that we have assigned the proper coordinate zone to this drawing, and that's the key to exporting to Google Earth. So let's do the function now. Under the application menu, if we go to Publish, oops, didn't go in the right one. We want to go to the application menu and then select Publish, Publish to Google Earth. This is the name, and I could call this Ross Street. And this is Ross Street Reconstruction. And this is www.vancouver.ca is the hyperlink. We'll publish all model space entities. And you can publish text, entity information, material information. We're going to use the drawing coordinate system transformation. And we're going to drape the entities on the ground because the vertical datum used in this data set will not match that of Google Earth. And this will create a KMZ file in the current folder with a drawing. So now when we click Publish, it's going to create that KMZ file, and now we can click View, and this will view that file in Google Earth. And you can see now, as we zoom into Vancouver, you're going to see Ross Street right here. There's Ross Street, and you can see how the data has been actually overlain directly on top of Ross Street. And if we were to look at the elevations, you can see how the data has been actually draped on that surface. So very nice to be able to use Google Earth to export data to. And there's Vancouver. So that concludes Lesson 3 in Unit 2 on surfaces.